Blockchains versus good old databases. In applications that we use every day like Facebook and Uber, the data is stored on machines controlled by a specific company. A company may have many different geographical locations around the world where they have servers, and copies of the data may be replicated across many machines. One of the reasons why this is done is to minimize latency for users from different countries and to ensure it can keep running even if a machine fails. We're all familiar with this model of storing data on servers. Although the data is distributed across the world across many machines, it is still considered centralized because it is controlled by a single entity, aka Facebook or Uber or Amazon or Google. Critics of the centralized model point to an over-concentration of power in the hands of a few, whether they be individual entrepreneurs or governments. How is the concept of blockchains different from this paradigm that has powered Web 1 and Web 2 so far? While Web 3 is still evolving and there are many different protocols emerging with variations on features, we can try to generalize on the commonalities and tease out what sets them apart from Web 2. I can throw out a Web 3 word salad such as trustlessness, decentralization, immutability, transparency, anonymity, but the problem with these definitions, other than abstractness, is that they're aspirational or ideological and may or may not be fully realized depending on the actual implementation. For example, just the trustless part can fuel hours of debate. I find it easier to think about blockchains as having three unique characteristics compared to quote-unquote normal databases running on normal servers. The what, the who, and the where. Firstly, what are you allowed to do on the database? Secondly, who is allowed to do it? And thirdly, where is the data stored physically? Let's start with the first, what you're allowed to do. If you've ever taken a Database 101 course, you would have heard about the acronym CRUD, C-R-U-D. It stands for Create, Read, Update, and Delete. These are the four most basic database operations. For example, we have a table of all the students in a school and their home addresses. With Create, we can add new students who join the school. With Read, we can see a list of all the students. With Update, we can change the address of a student if he moved house. And finally, with Delete, we can remove a student if he leaves the school. For normal Web 2 apps, all four CRUD operations are frequently used. In blockchains, you're only allowed to create and read, but not update and delete. You can think of it like a time-stamped log of historical events. At 9 a.m., Amy got on the school bus. At 9:30, she arrived at school. At 9:45, she entered the classroom. Once something is written to the chain, it can never be deleted or amended, just like you can't delete or rewrite history. You might ask, what if what was written to the chain is incorrect? Well, each protocol has their own rules to ensure what gets written to the chain meets a certain set of criteria, depending on what exactly the blockchain is for. For instance, with Bitcoin, if Alice wanted to send $10 from her Bitcoin wallet to Bob, the Bitcoin protocol is set up to ensure that Alice has enough money and has digitally signed the transaction before it can go on the chain. As another example, if there was a blockchain application that lets people bet on the weather, the blockchain would need some deterministic way of knowing the weather before it can write to the chain who needs to pay who. In this case, it might use the U.S. National Weather Service as the so-called oracle, which is just a trusted source that feeds the blockchain with real-world data. We'll come back to oracles later on in the series. Coming back to the three unique characteristics of blockchains. So no one's allowed to update or delete. So who is allowed to create and read? This comes to the second unique property of blockchains. Everyone. Everyone is allowed to do it, and the intent is that no one can stop you. And yes, not even the government or even the original inventors of the protocol. In Web 2, the company is the gatekeeper to all operations made to the database. Proponents of Web 3 equate this unique aspect of blockchains with freedom from government interference and big tech control. This is true to some extent, but my guess is, in practice for most people, they will likely be willing to cede some degree of control for convenience and regulatory protection. You might ask, if everyone can read everything on the chain, then what about privacy? Is all the information stored on the public blockchain available to the world? If my employer paid me for my remote work in crypto, does that mean everyone will know my salary? Great question. And on Bitcoin, for example, all someone needs to do is to associate you with your Bitcoin address and your pseudo-anonymity is blown. That being said, there are many creative solutions, and we will come back to this towards the end of the course when we learn about zero-knowledge proofs. Based on where things are headed, I would venture to say that there will be many ways to protect privacy on public blockchains now and into the future. Finally, the third characteristic of blockchains has to do with where. Physically, where is the data stored? For Facebook, we can point to precise addresses of data centers in the US, Denmark, Ireland, Singapore, where their servers sit. For blockchain data, where is it? In a sense, it's both nowhere and everywhere. It's nowhere in the sense that there isn't a deterministic list of physical locations where the data sits. It makes it hard for someone who wants to attack the system to take it down, as there is no critical points of vulnerability. It's completely decentralized. On the other hand, it's everywhere in the sense that a copy of the entire Bitcoin blockchain could be sitting in the computer in your neighbor's house next door. Anyone can help store parts of or the entire blockchain in their own computers by serving as a node. I could take a spare computer, connect it to my Wi-Fi, install the Bitcoin software, and contribute my computing power and disk space to the community. To summarize, this table outlines the what, the who, and the where, and it helps to separate Web 2 from Web 3. Note that most of the applications you will interface with will likely be some hybrid of Web 2 and Web 3 for a long time to come. All this might raise more questions than it answers. If everything is distributed, decentralized, and no one controls it, then who enforces the rules? And why would people volunteer their computers to become nodes? What if there aren't enough nodes, or all the nodes shut down their computers at the same time and the data is lost forever? This is what makes the design of blockchain protocols so ingenious and also so challenging at the same time. A combination of hash functions embedded inside the chain, combined with so-called consensus mechanisms and incentives, all work together to keep things on track. These are all meaty topics. We will cover them in upcoming videos.